Popular type of problem that uses the remainder theorem and specifically the factor theorem is given a factor of a polynomial and a missing coefficient, you are going to find that coefficient. So in this case, our missing coefficient we're labeling as k. You can do this with synthetic division, or you can do this using the factor theorem where you'll plug in. So option 1 is using synthetic division. We'll set that up. Remember to switch the sign, list out your coefficients. K is one of them, so we are left with a variable here, which we normally don't have in synthetic division. What we're going to do is, because we are saying that this is a factor, we are saying that the remainder is going to be 0. So we'll put 0 here. And what that allows us to do is we can work backwards a little bit. So this must be 0. Now, in order for that to be 0, we have to do negative 24 plus 24. In order to get 24, we would have had to multiply this number by negative 4. So that number is going to be negative 6. Negative 6 times negative 4 would give us 24. Now we're stuck here because we can't come up with the previous number without doing synthetic division going forward. So let's start the synthetic division, bring down the 1, multiply by negative 4. We'll add that to 5, so you'll get 1 again. Then do negative 4 times 1, we'll get negative 4 here. And normally we would add that result to the number above. We don't know what that is, so we're going to do k plus negative 4 equals negative 6. So k minus 4 equals negative 6. Add the 4 to both sides, and we get a result of k is equal to negative 2. So that's one option. We're going to do a second one that will give us that same result. I'm going to do it on the next page because I don't have enough space here. In this one, we're going to use the factor theorem. We'll plug in negative 4 and set that equation equal to 0. So here, we're using the fact that x is equal to negative 4. Using the remainder theorem, f of negative 4 is going to equal 0. Just like we got the remainder of 0 before, we're going to set the equation equal. So we'll plug that in. Negative 4 cubed plus 5 times negative 4 squared plus k times negative 4 minus 24 equals 0. You can calculate all in one shot in your calculator the things I'm underlining in blue. So negative 4 cubed plus 5 times negative 4 squared minus 24. That's going to give us an answer of negative 8. You can pause the video and check that. And k times negative 4 will be minus 4k. Again, that's still equal to 0. So now you have an equation to solve for k, just like we had in the previous. It's a different equation because we're solving it a different way, but your end result should be the same. And we do, again, get k is equal to negative 2. So there are two options there. You can really go with either one. The last example I'm going to recommend going with this option of plugging it in because it's just going to be easier to figure out. But with these you could use synthetic division or the substitution. So we're going to do the next example with the factor theorem again. This is a bigger polynomial. Just be careful when you look at it that nothing is skipped. Again, we're going to use the fact that x equals 9. And we're going to plug in and set that equation equal to 0. So we'll do 9 to the 5th minus 19 times 9 to the 4th plus k times 9 cubed plus 100 times 9 squared minus 94 times 9 plus 36. Just made it. Set that equal to 0. Sorry for squishing that in. Alright, so anyway, we're going to then calculate everything underlined in red. It's pretty much everything except for the term with k. So 9 to the 5th minus 19 times 9 to the 4th plus 100 times 9 squared minus 94 times 9 plus 36. I would recommend doing it once and then maybe redoing it just to be on the safe side. That's going to give us a negative, oops, I might as well keep it in red, 5, 8, 3, 2, 0. And if you do 9 to the third, you'll get 729, so that gives us 729k. Again, that's still equal to 0. So we'll add the 5, 8, 3, 2, 0 to both sides, and divide by 729. That will give us a k value of 80. Again, you can always check this by putting the 80 right into this spot here and just recalculating and making sure you do get it equal to 0. That's a good way to check it with the calculator when you're doing your practice. And then the last one we'll also do with the direct substitution. It's pretty much, I mean, you could try to do it with the synthetic division. I think it would be a little confusing. And I'm going to move on to another page just to give some more space to do it. But this one ends up being something that we have to factor later on when we set it equal to 0. So we are going to just switch the sign, so x is equal to 4. Plug that in every time you see x. So just be careful with this. It's going to look a little weird since we have the k in 2 spots. Set it equal to 0 like we did before. That's the important piece of this. The remainder is 0, or set it equal to 0. We're going to get a quadratic, 16x squared minus, or k squared, sorry, 24k plus 9. I keep saying x, sorry about that. And then this is something that you can factor. It ends up being what's called a perfect square trinomial. So you'll notice if we list out the factors for these, the first and last term both have perfect square factors. Those are the ones to try, and then remember that your sign in the middle should match up. So 4k minus 3 times 4k minus 3, you can check that. This is negative 12k and negative 12k. That does give you the negative 24 that you'd be looking for factoring. They're the same parentheses, so I'm just going to set one of them equal to 0 because you don't have to do both, and solve. So we end up getting k as 3/4. A lot of times you will get a fraction as an answer for problems like this. This is a similar one to a Park type question. So it's a good one to do with the direct substitution, and a good one to kind of review and make sure you're comfortable with.